Dear students, myself I am Mamta Devi AB, Assistant Professor of Chemistry. In this video, I am going to explain session 44 of Ionic Equilibria. The content of this video are: first one, hydrolysis of salts of weak acids and weak bases, that is, relation between degree of hydrolysis and hydrolysis constant in the hydrolysis of salts of weak acids and weak bases. Second one, relationship between KH, KW, Ka and Kb in the hydrolysis of salt of weak acids and weak bases. Hydrolysis of salts. Hydrolysis of salt is defined as interaction of ions of salt with oppositely charged ions of water to give acidic or basic or neutral solutions. Degree of hydrolysis, that is H. The fraction of the salt hydrolyzed at equilibrium is called degree of hydrolysis. Hydrolysis constant, that is Kh. A hydrolysis constant is equilibrium constant for a hydrolysis reaction. A. Relation between degree of hydrolysis and hydrolysis constant in the case of hydrolysis of salts of weak acids and weak bases. Example, ammonium acetate. Consider the hydrolysis of ammonium acetate, which is a salt of weak acid and weak base. Ammonium acetate dissociates in solution to form ammonium and acetate ions. Water ionizes slightly. The hydroxide ions of water attack the ammonium ions of salt to form ammonium hydroxide, which is poorly ionized. Let C mole per dm cube be the initial concentration of the ammonium acetate. Let H be the fraction of the salt hydrolyzed at equilibrium. Then concentration of the various species present in the equilibrium are: acetate ion and ammonium ion undergo hydrolysis to give acetic acid and ammonium hydroxide. Initial concentration of acetate ion is C. Initial concentration of ammonium ion is C. Concentration of acetate ion at equilibrium is C into 1 minus H. Concentration of ammonium ion at equilibrium is C into 1 minus H, whereas the concentration of acetic acid as well as ammonium hydroxide at equilibrium are CH and CH respectively. Hydrolysis constant Kh is defined as the ratio of product of concentration of acetic acid and ammonium hydroxide to concentration of acetate ion as well as ammonium ion. Substituting the concentration of these species, we get Kh is equal to H square divided by 1 minus H whole square. Call this as equation 1. As 1 minus H is small when compared to 1, then 1 minus H is nearly equal to 1. So equation 1 becomes Kh is equal to H square, or square root of Kh is equal to H. Call this as equation 2. The equation 2 gives the relation between H and Kh in the case of hydrolysis of salts of weak acid and weak base. Second one, relationship between Kh, Kw, Ka and Kb in the hydrolysis of weak acids and weak bases. We know that Kh is equal to Kw divided by Ka into Kb in the case of hydrolysis of salt of weak acid and weak base. Therefore, equation 2 becomes H is equal to square root of Kw divided by Ka into Kb. Call this as equation 3. Thus, equation 3 gives relation between degree of hydrolysis, ionic product of water, dissociation constant of acid and dissociation constant of base in the case of hydrolysis of salt of weak acid and weak base. Session summary. A. Hydrolysis of salts of weak acid and weak bases, that is, relation between degree of hydrolysis and hydrolysis constant in the hydrolysis of salts of weak acids and weak bases. B. Relationship between Kh, Kw, Ka and Kb in the hydrolysis of salt of weak acid and weak bases. If you want to refer more about these topics, then refer Physical Chemistry by P. W. Atkins, Physical Chemistry by W. J. Morey, Principles of Physical Chemistry by Puri, Sharma and Patania, Swayam platform. Physical Chemistry by R.L. Madan and J.D. Tuli. Textbook of Advanced Physical Chemistry by Gurudeep Raj. Thank you.